Okay, welcome back. We have question 3 now, which has got a change in the shifter or the phase change. Oh, I wonder how that will work. I wonder how that will be. So we've got A, I'll do them separately. Y equals sine x minus pi on 6. Cool. So the period equals 2 pi divided by 1, which is 2 pi. So we're settled on that. The period, the phase change or the shift or the displacement, okay, I'll just do this once. Displacement, phase change or shift, whichever phrase you want to use, is fine. So all of those three things here will be minus C on V. So here we have, be careful now, minus pi on 6 divided by B, which is 1. So we get a phase change of pi on 6 plus pi on 6. Did you notice that? Minus times a minus is a plus. The equation is like what we do in the quadratic formula. We have minus B. It's a minus is a plus. Okay, so we're well enough now to put together a picture of this. So let's go back and do what? What are we going to do? Really? Yes, we are. Yes, we are. We're going to do a sine wave. And the sine wave is going to go like that. Actually, I'm going to make that a bit bigger because this is sine. Amplitude's the same, so I'll make it a bit bigger. Up you go. Sine wave. Beautiful sine wave. Down you come. Lovely maximum gradient. And the height's about there, isn't it? Coming down, swooping. Up we go. So we've got the comparison point. We've got our pi and our 180, 360, whatever you want to call it. Okay? Now, two things. The period is 2 pi, so it's a match. We're going to finish here at 2 pi, except that it's not 2 pi, it's pi on 6. So how do we do that? Well, here's pi. Let's divide it up into 6. Divide it into halves. 1, 2, 3, 4. Well, that didn't work. Halves again will give me 8. Ding, ding, ding. That's no good. So we need another strategy. How do we divide it up into 6s? Let's try again. Let's divide it up into thirds. So middle third. What do you reckon about there? There, 1, 2, 3. Well, let's divide those in half. 1, 2, 3, 4, 5, 6. It's a winner. So what we've done is we've managed to put in pi on 6. Now look, this says do not start until pi is 6. Pi on 6. So our sine wave is not starting until here, which means that it's not finishing until here. 2 pi plus pi on 6. What's 2 pi plus pi on 6? 2 pi, all adding fractions. 6. 12 pi, 13 pi on 6. 13 pi on 6. Very good. 13 pi on 6. That's what she said. This is pi on 6, isn't it? So we're going to be late with everything. Later. We're going to be later with everything. So we'll do it in a different colour. Red. Up you go. Beautiful swooping up. Beautiful. Swooping down. Swooping down. Swooping up. Okay, so we've got some points where we can check. some values. Okay, we've already got that 2 pi. 2 pi is where it's cutting the axis. Okay, so if we had pi on 6, we had 1, 2, 3, 4 lots of pi on 6, which is 2/3 pi. 2/3 pi. Because it's just a little bit ahead of half. Pi plus pi on 6, 7 pi. Isn't it? 7 pi on 6. That's the halfway point. 13 pi. 2 pi on 1 times 6 is 12 pi, plus 1 is 13 pi on 6. 1, 2, 3, 4, 5, 6, 7 pi on 6. 13, oh, that's 14, isn't it? You got to add 1. 14 pi on 6. No, that's not right. It sometimes does this. Sometimes. $12 pi plus 2 pi, or 13 pi. That's it. Leave that as 13. Sorry. 13 pi on 6. What about this one here? We'll break up pi into 1, 2, 3, 4, 5. There's another one there. 1, 2, 3, 4. 1, 2, 3, 4. So this one here is a little bit wide. I've just been a little bit careless in the application of that. So I needed to be more careful. Okay, so this second pi had to be split up into thirds. So repeat. It's more sensible. So we're going 1, 2, 6. That's correct. 1, 2, 3, 4, 5, 6. So that's better. Okay, very straightforward to do all of that. Just put them in, count them up, and add them. Okay. All right, let's keep moving. We've got lots to do. That was actually the end of that first part of the tube. So that's helpful. All right, so let's have a look at these problems, and we'll see if we can't iron these out as well. All right, so sketching the graphs is also very helpful and fun, but second part of tute. So 1, A is sine 75. So what do we do for sine 75? Well, guess what? We did a little bit of this recently. So we're going to add 2 parts. The sum means that we'll have sine 45 cos 30 plus cos 45 and sine 30. Now where are we going to get all this information from? Sine 45 degrees. It's the same angle. That's the one with the same x and the same y. So the y, sine 45, is 1 on root 2. Cos 30, the x in the 30-60 triangle. In 30, it's laying over, isn't it? So cos is this big, long part, root 3 on 2. If you haven't done your white sheet, you have no idea what I'm talking about. The x part of cos 45, 1 on root 2, it's all in the first quadrant, so we don't need to worry about negatives. And the sine of the 30, it's a little bit, this big. So it's a half. This is absolutely essential for you to be able to do this. So we've got root 3 on 2 root 2. And 1 on 2 root 2. They're the same family. So we can have root 3 plus 1 over 2 root 2. Now I'm happy with that, but some lecturers will want you to do another step, which is to rationalise the denominator. And the way that we do that is that we don't change this quotient, we just multiply it by 1. And the form of 1 that we're interested in is 2 root 2. So that's our form of 1 in disguise, so it won't change anything. 2 root 2, 2 2's are 4, so I'm going to put them out separately. And then the root 2 squared is just 2. Now I haven't made that 8, I've left it as 2. And the reason for that is because I have got this up here, which is a product. That's not a product inside there, that's an algebra plus, so be careful. But this is a product, so that means that can cancel. So by leaving that there and not making it 8, I now have the bracket root 3 plus 1, root 2, which is to be expanded, over just 4 now. So if we do the expansion, we'll get root 2, root 3, plus root 2, over 4. Now this first one here, this is me being a long way teacher. 2 times 3, isn't it? That's what you're allowed to do. So we've done an expansion. All of this stuff looks tricky, doesn't it? Root 6, if your gymnastics are no good. Root 2 over 4. And that's the answer. Okay, if you use Wolfram to put this together, it would do this. Okay, it would give the quarter out the front. Because the split fraction would have the 4 on both, but there's no point doing that. So it would just have the quarter out the front. And these are different families, so apples and oranges can't be added together. They're not the same family. So any one of those, for me, is a good answer. Okay, but that's typical of the kind of thing that you would get refined if you're using different curriculum systems, and that's all it boils down to. It's not really, a solid maths decision how you finish that up. It's more about how the question was written. Convention allows you to leave it in a number of different forms. All right. Although some would argue, oh, well, at this place we do it this particular way. Oh, well, that's very good. I'm a bit ambivalent because I want you to develop intuition. All right, so 1A, very good. 1B, you can, 1B, so, well, 1B, I don't know what I'm doing there. Making a flag hole. What am I thinking about? B is cos 15. How would we get to cos 15 degrees? Well, it turns out that we might be looking for a difference. Okay, we might be looking for a difference. And the difference would be 45 take away 30. So we're back to doing 45s and 30s again. Do you know it? Are you familiar with it? Don't know. That's cos version. So we'll end up with cos cos. Cos 30. And then sine sine. Very good. So then we have to go to our exact values trig, and we have to say to ourselves, cos 45, that's the same angle, same sides, 1 on root 2 here, 1 on root 2 here. Cos 30, sine 30, it's the 30 degree triangle, it's the one sitting over a little bit. Sine is a half, cos is root 3 on 2, the x. So cos 45 is 1 on root 2. Cos 30 is the x of the 30 degree triangle. If you've been doing your white sheet, you know that. Sine 45 is the y part of the same thing, same as the x, same proportion, same. Sine 30 is the little one, it's the one that's sticking up. Okay, so if we put them all together, we'll get root 3 on 2 root 2. This looks familiar, doesn't it? And so we've completed the problem, and we've got 1 over 2 root 2. They're the same family, so this time This time I'm just checking that it's still plus. Just want to check that it's still plus. Still plus. So this is exactly the same as before. Root 3 plus 1 over its common family, 2 root 2. So for me that's an answer, but you'll notice that it's the same one that we had up here, root 3 plus. Okay, so I want to check that. I'm going to use technology to help me check that because I'm too lazy to go looking for my equation sheet. That tells me if I put in sine 15, what do I get? I get an exact roll. Now, there's a mistake in what I did. See that? Root 3 minus. So what that tells me, oh, wait a minute, it might not be. I put sine cos 15. It's plus. 1 over root's plus. So all's well that ends well. There you go, there's the 1/4. So it's all good. Exactly the same. And you can do your 1/4 root 3 plus 1 root 6 plus root 3. That's what it is. Yeah, root 6 and root 2. So that's the other version after you've gone through the working. Same as you did up here. What's the difference? Well, that one was sine. That's why I was worried about the minus. This is cos, so that's good. Alright, tan 15. Tan 15. So how do we do tan 15? Tan 15 is going to be made up of something else, isn't it? Can we make that up as tan 45 minus 30? That would be good. Then there's an equivalent, isn't there? Tan 45. Now I think in the workshop I did say that if it's tan pi on 2, which is 90, it's undefined. But this is not 90, it's 45, so this can be processed. You can look the workshop video up to see what it is that I'm actually talking about. I'm just going to hive that around there so we know that when we come to do our sum at the bottom, it's just that, a sum. This is a product, but the other one's sum. So we're just hiving off the algebra. So that's fair enough. Okay, now how do we get to tan 45 and tan 30? Well, we need our two triangles. There's our 45-degree triangle. Same. 1 over root 2. 1 over root 2. So tan 45 is opposite over adjacent. So 1 over root 2 divided by 1 over root 2, which is equal to 1 over root 2 divided by 1 over root 2. You're taking the long way, which is equal to 1 over root 2 times root 2 over 1. Oh my goodness gracious. Tan 45 has an equivalent of 1. So everywhere there's a 1. Alright, what about root 3 on 2? What did you do? 30 degrees. There you go. Half root 3 on 2. That's it. Tan is opposite, so it's a half divided by root 3 on 2, which is a half. Yeah, I know. But you're a lot smarter than me. I have to work these things out. Root 3. Oops. So we get 1 over root 3. So tan 30 is 1 over root 3. So that's 1 over root 3. 1 over root 3. So I can now populate all of that. So we've got a numerator with 1 minus 1 over root 3, adding fractions. It never leaves you. 1 plus 1 over root 3. So to finish those off, we've got to make them the same family. So it'll be root 3, same family, root 3. So the top one will be root 3 minus 1 over root 3, divided by root 3, root 3 plus 1 over root 3. Okay, so we're just going to finish that off a little bit easier. So what we've got is root 3 minus 1 over root 3 divided by root 3. Yes, I know. You could have done it in one step, but I need to work it out. Times root 3 over root 3 plus 1. They're going to cancel. So we get root 3 minus 1, root 3 plus 1. So that's our final answer. Okay? And that's how we arrived at it. So it's important to follow through with all of these things. All right, I'll be back to do the next question in the next episode. Back soon.